Hi everybody, my name is Brandon Lopez and I will be teaching you how to do operations on functions. There are actually 4 ways of doing operations on functions. One of which being addition, the second being subtraction, the third being division, and the fourth being multiplication. Okay. One of the 4 ways you can use operations on functions is addition. As you can see here, f of x equals 2x plus 3, and g of x equals x squared. Once you add the terms together, whether they are alike or different, once in the proper equation, just add them together to make them into a descending order of x's. Now I will be showing you a practice problem on addition of operations on functions. So give me 1 minute, I'm going to be writing. I'm a left-handed person, so it's kind of difficult for me to be writing on a whiteboard in the first place, but I will do my best. So the problem is, f plus g, in parentheses, x equals, I'll just continue it down here, 2x plus 3 plus x squared. So once again, I'm very sorry, I'm a left-handed person, and it is quite difficult for me to be writing on a whiteboard because there's no cushion for me to be planting my hand on to write on, so excuse that bad writing. So after doing this, you want to simplify it and make it into a descending order of x's in the first place. So with the x squared, since it has the most amount of x's, and then 2x has the second amount of x's, you're going to put x squared plus 2x plus 3. So it will look like x squared plus 2x plus 3. And that is your final answer. And also the notation for addition is as followed. F plus g times x equals f of x plus g of x. So that's also another thing. And also note, depending on the equation, you may have to combine like terms, therefore altering the number of descending x's. Okay, so the second way you use operations on functions is subtraction. For subtraction, you just have to subtract like terms and simplify if necessary. And once again, you have to put the x's in descending order. So the notation is as followed for subtraction. F minus g times x equals f of x minus g of x. So, the end. I'm just kidding, we're just halfway there. So, right now we're going to pick it up with multiplication. And here we go. And the third way of doing operations on functions is multiplication. And I flipped to the wrong page, excuse me. With the same with addition, the order of listed quantities will never affect the final answer. So as long as you use PEMDAS and you follow the order of operations, you'll be fine on this. So therefore, if you know parentheses, exponents, multiplication, division, addition, subtraction, you'll do fine on this. So let me explain and go on to the notation. The notation is as followed for multiplication. So the notation goes F times G times X equals f of x times g of x. So f times g times x equals f of x times g of x. So that's the notation for multiplication, and moving right on to division. Hello, and this is the example for multiplication. Excuse my height and my writing, please. So as you can see, we started off with f times g times x equals f of x times g of x. This equals 2x squared minus 3x plus 4 times the quantity of x plus 3. So for this, you use the distributive property and you distribute x plus 3 to each one of the factors in 2x squared minus 3x plus 4. So after you do that, you combine like terms. So as you can see here, we drew an arrow down signifying what the next step is, which is the distribution part. So you get 2x squared times x plus 2x squared times x plus 2x squared times 3. One second. Whoops, excuse me, I actually wrote this twice, so I can take that out. So it's going to be 2x squared times x plus 2x squared times 3 plus negative 3x times 3 plus 4x plus, or 4 times x plus 4 times 3. And once you simplify those and distribute them, you get 2x squared times x plus 2x squared times 3 plus negative 3x times x plus negative 3x times x plus negative 3x times 3 plus 4x plus 4 times x plus 4 times 3, and further simplifying is 2x to the third plus 6x squared minus 3x squared minus 9x plus 4x plus 12. So once you do that, you want to combine all like terms. So you look for any terms that have x to the third, x to the second power, and x by itself. And in our case, we actually have 6x and 3x squared that simplify and add. So 6 minus 3, since it's a negative, it is 3x squared, and that's going to be given in 1 second. And we also have 9x and 4x. Due to it being a negative 9, it's going to turn out to be a negative 5 in the final answer. And your last step is just putting them in the descending order of x's, which they should already be in. If they're not, you must do it. And it will turn out to be 2x to the third plus 3x squared minus 5x plus 12. And that is your final answer. Fourth way of operations on functions is division. As you can see right here, the notation is as follows. F divided by g times the quantity of x equals f times x divided by g of x. And note that g of x cannot equal 0. It does not equal 0. Division is much referred to as the easiest of the 4 operations on functions, and for the steps, these are as follows. The first step is that you create a rational function and actually put the f of x in the numerator and put the g of x in the denominator, and you'll be set on division. The composition of functions. The final thing in Chapter 7, Section 1. In the composition of functions, the notation is as follows. Instead of writing this right over here, I just wrote it underneath to avoid problems with my head being in the way. I'm sorry. The composition of functions is when a function is performed and then a second function is performed on the result of the first one. Excuse me. Evaluation is key in compositions. If you pinpoint a specific part where you can simplify as you proceed, it will make it a lot easier. So please, if you can pinpoint a specific part where you can simplify, it'll be awesome. Plug in numbers and proceed. First, plug in x into a function, following plugging in x again to another function. Watch as I proceed with my example. So you're given two different equations as you're given. One of them being f of x equals 2x plus 3, and the second one being g of x equals negative x squared plus 5. You have to find f of g times x. So you have to find the formula that results in plugging in g of x into a formula for f of x. So as we go, we simplify, or we bring x squared plus 5 into f, and we basically move x squared plus 5 into 2 parentheses plus 3, because you're substituting negative x squared plus 5 into that x, 2 times the quantity of negative x squared plus 5, or plus 3 at the end, therefore giving you negative 2x squared plus 10 plus 3, and therefore simplifying further to 2x squared plus 13. Also note, for this example, I'm not trying to find any numerical values. Therefore, I'm just trying to find the formula to substitute f of x for g of x. It may get more complex as you proceed into the composition of functions. Thank you.